This video is an introduction to the comparison test. So the main idea for the comparison test is to compare the given series to the one that we know is convergent or divergent. And since comparison will be involved in the process, we need to practice and learn how to compare expressions, because that's something that we have to be careful with and not to make quick conclusions. We can easily compare expressions in a fraction form when they have either same numerators or same denominators, and that's something that I was trying to describe here in general. So this is the first case. The first case when the numerators are the same, but the denominators are different, and we can describe the denominators as one denominator is larger than the other denominator. I tried to use different size letters here to emphasize that this denominator is bigger and this denominator is smaller. So try to think, what sign do we have to place here? Greater sign or less sign? So the numerators are the same. In one case, you're dividing by the bigger number, and in another case, you're dividing by the smaller number. So what can we say about that? Well, we can say that the first expression, the one where we're dividing by the bigger number, will produce smaller result, right? So that means that we have to use less sign. How about the second case? In the second case, we have same denominators. And numerators are different. So we have larger numerator and smaller numerator. So let's think what symbol we have to use here, greater or less. So larger numerator being divided by something versus smaller numerator being divided by same thing. So what can we say about those two expressions? Well, the one that has larger denominator will be larger expression, right? Since we're dividing by the same. So that's the overall idea. Let's practice that. So for example, for the first example here, I have to compare, again, by using less or greater symbols, compare those two expressions, 1 over 2n plus 1, and then 1 over 2 to the power n. What can I say about those two expressions? Well, I can see that numerators are the same, so we're dividing same number by two different expressions. What can we say about them? We can see that the first denominator is 1 more than the second denominator, so it's a larger denominator, it's larger by 1. So same quantity, we're dividing by something larger compared to the second fraction. So what can we say about this expression? Well, since we're dividing by something that's larger, the overall expression will be smaller, so we'll have to use less. So here we have bigger denominator. How about example B? What can we say about the example B? Same numerators, right? And make sure that something is the same, either numerators or denominators. But what can we say about the denominators? So here we have 2n squared plus 4n plus 3, and here we have 2n squared. Well, we can notice how we have this extra 4n plus 3 added to the first denominator. And since this is all defined for n values that are greater than or equal to 1, we know that that quantity is positive, right? So we have same portions, but second denominator has, first denominator has extra 4n plus 3, so it makes it a larger denominator, so bigger denominator again. And since it's the bigger denominator, it means that the overall quantity will be smaller, so I have to use less sign. And finally, example C. What can we say about that, about those two? This time we have same denominators. So that means that we really need to compare the numerators. So what can we say about ln and then 1? Well, we have to keep in mind that this is defined for n values that are greater than or equal to 3. And we know that as n increases, this quantity will increase. But what can we say about it at the smallest possible value of n, at 3? Well, if we take calculator, then we'll find that ln of 3 is approximately 1.099. So even at the smallest possible value of n, this value is greater than 1. So that means that we're looking at the bigger numerator or larger numerator. So then how do we compare those two quantities? Well, in this case, we have to use greater sign. It's the larger quantity versus the smaller quantity being divided by the same. So that makes the first expression greater than the second expression. So that's the overall idea that we need to understand when we compare quantities, especially when they're also expressed in the general form. And here's the comparison test. So when we use comparison test, we consider two series. Well, usually one of them is our series, and the other one series for which we know whether it's convergent or divergent. So a good candidate for that would be, let's say, P series, because it's easier to determine convergence or divergence for the P series. Okay, so if we have those two series with positive terms, that's important, and we know that terms of the first series are consistently less than or equal to than the terms of the second one for all n, then this is how it works. If series that involves larger terms converges, so that means that it equals to a finite sum. That means that the series that has smaller terms also convergent. So if you add larger numbers together, you get finite sum. Well, it's definitely if you add smaller numbers together, you're gonna get finite sum, right? So that's kind of the idea. And now, if the series with the smaller terms divergent, so if series a sub n is divergent, so series with the smaller terms is divergent, that means that the sum is infinity. Then the larger series also has to be divergent. So if you add up smaller terms and you end up with a infinite sum, infinity, then definitely when you add up larger terms, you're also gonna get infinity. So try to understand comparison test. Will not memorize it, but try to understand the logic behind it, because it's easy to get confused when you just memorize it without understanding. But if you understand how it works, then it's actually pretty easy and good test to use. And here we have same thing described in words. I kind of already said that. So we're going to look at a few examples in the next video.